morning, this is Jean-François from Chrysalide Laboratories, and I want to design this open source kit, which consists of essentially one main measuring board. The board has 4 banana jack, power supply, input and output. The input works from 0 to 30 volts and the output 0 to 10 volts. So we have a potentiometer for the output and the display on LCD and calibration by MCU and trim button. We are going to manufacture only the base plate, which is, according to this schematic, has a protection for the input signals. We need to make a 5 volt regulated, and we need a buffer to make from the 10 volt Zener reference our output signal. And there's a small mistake over here. We need to take this signal 0 to 10 volts from a potentiometer back to the output. That's how this will work actually. And the signal will be approximately 10 Hz of filtering over here, and we go to a delta sigma IDC, and I could not find an easy solution to display the values efficiently on price and complexity, because modern ADC that have a good specification also have a serial output, SPI or SQC, so that's what we're going to do. And this is a single channel, but this is the spec and the wiring diagram for one channel. And then in future, if we want to make more complicated kits, 2 or 4 channels, and that supports differential measurement, we will be able to export from this kit, make a variant of it. We are going to work through the KiCad schematic, and first I drafted this schematic over here. Let's go implementation. The first thing we want to do is add a connector banana plug. Over here we have 4 channel power supply input output. Now if we check this symbol from KiCad, there is an issue, that is the distance is non-standard. We have 2 ways to do this. Either we could use 4 connector or 2 times the 2 connector from KiCad library, but we are going to make them one by one. Here is the reason. If I implement the standard layout and measure the distance between plugs, we see 15 mm and 30 mm. What we want to do is 3/4 of an inch is 19.05 mm. That's the standard plug-in dimensions for banana, so that lab instruments and lab plugs can work with this design. Next thing we have to do is place the power plates. So we put ground, we put 12 volt P, 12 volts. 12 volt P stands for protected. 12 volt will be the external one. We have to have ground. We have to have power flags. We have our plugs. 12 volt will only be used until the fuse. The supply negative is the ground. And we have symbols for the 2 signals input output. And we have our fuse and TVS, the voltage suppressor, high voltage suppressor. At a later stage we are going to need to use a buffer and some kind of ampli up. And so the 12 volts input, we need to protect it to somewhere between 18 and 30 volts. That will be the rating of this ampli up. In fact, we need a 12 volt ampli up, but we don't want to be on show margin. And also we want to have some margin on the power supply input. 12 volts come unregulated, and sometimes they can have 12 volts at 1 amp load, but they can have, we don't know exactly what will be our power supply. So we want to support about approximately 20 volts of maximum input. So that's what we are going to use on the TVS selection over here. We are going to use the same component for the supply and the output protection, rated at 18 volts and 32 volts for the input. We're going to select the components so that they have a small margin. They start to conduct strictly above 18 volts at any condition, operating condition, and same 32 volts for the input, which means they can start to block real high current, about 36 volts for the input and about 24 volts for the supply and the output, which will be fine because the output, even though it's high voltage, we will go through a resistor bridge over here, so we don't have any issue with this 32 volts anyway. This schematic has been completed. There are some additional informations on why we use this specific amplifier, why we generate some negative rails, the tolerance of the components, and the way the system works, the reason for this optimized schematic. The rest of this description will be much more detailed. I want to place the follow-up on this project for this station on Patreon. There will be short 5 minutes introduction to every step of this project, public, and detailed information down the test points, the criteria and the results, and all the technical details on the design, the performance, as well as the schematics will be shared for the Patreon community. But I hope we can keep in touch, and I will publish some information. Anyway, that's the final schema. This will be a single board of itself. Thank you and keep in touch. Bye bye.